Okay, so welcome to our next video on complex numbers. This is again on the conjugate root theorem. So here's our question here. We have a polynomial, which is just a fancy word of kind of an equation, or there's a cubic function or polynomial, whatever you want to call it. So we have 3z cubed minus 5z squared plus 13z plus 5. Okay, the fact that there are z's in it, that tells us it's going to be complex. So obviously, since there's a video on complex numbers, we know it's going to be complex, but if you see it in an exam and you see a z instead of an x, chances are you're going to be dealing with something with a complex root. Okay, so that's one little hint. So we'll start with question 1 anyway. How many roots are there? There are going to be 3 roots, and the reason for that is, we explained in the last video that any polynomial, so again any kind of function or anything like this, has as many roots as the highest degree. So in this one, the highest degree is 3, because it's 3z cubed. So the highest number, the highest power is 3, and that's how many roots there are going to be, okay? Yeah, that's all there is really to that. Question 2 then. If z is equal to 1 plus 2i as a root, find another root. So if z is equal to 1 plus 2i as a root, we know that z bar is equal to 1 minus 2i. This is the conjugate. So this is the conjugate root theorem. We know that if 1 plus 2i is a root, then 1 minus 2i has to also be a root, as long as all of these are real coefficients. So they are. There's no I anywhere here. They're all numbers. So we're good for that. Okay, so we have 2 of the roots now. Now it says find the last roots. We have 2 roots. We know there's going to be 3 roots. Okay, so first I'm just going to talk a little bit about the third root. So the third root is going to be a real root, okay? And the reason we know that is because we already have these 2 roots here are going to be complex. And complex roots always come in pairs. There's always the complex root and the conjugate root. So the last root has to be real, because there has to be a pair of complex roots. So, yeah, real root, because the last one, yeah, because the other 2 have to be complex. Okay, so now how do we find the last root? So this is kind of the main bit of the question. Okay, so it's kind of like back when we were talking about quadratics and x's and algebra and stuff. So I'm just going to draw a line. Z is equal to 1 plus 2i. Okay, that's the root. That means the factor is, excuse that. The factor is going to be z minus 1 minus 2i is equal to 0. Yeah, so if you remember, that looks kind of like a factor like we would have had with algebra. And again, this one here, z bar is equal to 1 minus 2i. So then z minus 1 plus 2i is the other factor. Okay, so I'm not going to write the z bar for this one. So here are 2 factors of this polynomial here. So if we multiply these 2 by each other, by the last factor, we will get our polynomial here, because that's what factors are. They're the things that you multiply by each other to get your original thing, your original polynomial. Okay? Okay, so if we multiply these 2 by each other, so I'm going to go ahead and do that. Z minus 1 minus 2i, and then z minus 1 plus 2i, multiply by each other. So this will take a while, because there are 3 terms in each. So z by each term, then minus 1 by each term, and then minus 2i by each term. So start with the z. I'm going to do this in green. We're going to get z squared minus z plus 2iz. Okay, so z by z is z squared, z by minus 1 is minus z, and then z by plus 2i is plus 2iz. Now minus 1 by each thing, we're going to have minus z plus 1, because minus 1 by z is minus z, minus 1 by minus 1 is going to be plus 1, because minus by minus is plus, and then minus 1 by plus 2i is going to be minus 2i, and the last one, minus 2i by z is going to be minus 2iz, minus 2i by minus 1 is going to be plus 2i, and the last one then is going to be minus 4i squared. Okay, I'll get my blue thing out here. So plus 2iz and minus 2iz are going to go to 0, as well as that minus 2i and plus 2i. So you shouldn't get any i's in your final thing here, okay? So now we're going to go ahead. It's going to be z squared minus 2z, because it's minus z and it's minus z. And the last one, we have plus 1 and minus 4i squared. So remember, minus 4i squared is going to be minus 4 by minus 1, because I squared is equal to minus 1, so it's going to be plus 4. So plus 1 plus 4, sorry, is going to be plus 5 as our final answer. So hopefully I didn't over confuse that. Remember, I squared is always minus 1, so it'll change the sign on the 4 here. So this is our quadratic. So if we multiply these two factors by each other, we get this quadratic. Okay. Now the last bit here is if we divide this quadratic into our original polynomial here, we should get the last factor. Does that make sense? Because if you multiply these three factors by each other, so this factor, and the last factor we're looking for, we'll get this. So we already multiplied these two factors by each other to get this. So hopefully we can find the third factor now. So I will have to erase this to make space, so just bear with me 1 second. Okay, I think we're back. Yeah, sorry, just erase that there. Z squared minus 2z plus 5, algebraic long division, into 3z cubed minus 5z squared. So 3z cubed minus 5z squared plus 13z plus 5. Okay, so algebraic long division. We'll just go ahead and bang through this. So z squared into 3z, so that should be cubed, forgive me, is going to be 3z. Okay, now we multiply 3z by each term here. We're going to get 3z cubed minus 6z squared plus 15z. Draw our line, change the signs. We're going to be left here with z squared minus 2z and then plus 5 because we bring this down. Okay, now z squared into z squared is going to give us plus 1. Now plus 1 by each thing here is going to give us z squared minus 2z plus 5. So they're both the same, which is a good sign. We're going to go minus, plus, and minus, finish with 0. So that means that this is a factor of this, so this is all good. And now we've found our third factor here. Okay? So again, not much space, but I'm just going to draw a little box here. Okay? So 3z plus 1 is our last factor. 3z plus 1, I'm going to say, is equal to 0. So this is how you get the roots. So if we know that 3z plus 1 is a factor, then 3z is equal to minus 1, and that z is equal to minus 1 over 3. And this is our last root. Okay? Yeah, so hopefully that all made sense. So that's the method. If you want to find, if you have two roots and you want to find the last root, you have to turn them into factors and then go through this process here. Okay, so that's the way to find your third root. So our three roots are 1 plus 2i, 1 minus 2i, and minus the third. Okay, so again, I'm just going to do a quick little sketch here. So this isn't completely vital, but it's still good to know. So a cubic, remember a cubic function is always going to be like this. It's going to look something like that. Okay, and we know just from the information we have here that there are two complex roots and one real root, that our cubic here is going to look something like this. Doesn't matter where it hits, it's just that there's one real root, that means it hits the x-axis once, and two imaginary or two complex roots, it means the second bend in it doesn't hit the x-axis. Okay, so that might come up, it might not come up, but it's still good to know. Okay, hope the video helped.